Hello everyone, welcome back to my YouTube channel. Let's encode the logic. I hope you all are doing good. In this video, we are going to discuss a program to convert a decimal number to a binary number. So without making any delay, let's quickly jump into the discussion. So let's see the binary conversion of a decimal number 11. So what we will do usually, if we want to find out a binary conversion of any decimal number, we will divide that decimal number with 2, right? So let's do that. It was 11. So the quotient was 5, right? 2 5s are 10 and the remainder was 1. Okay. And I will again take this quotient and I will again divide this quotient with 2. 2 2s are 4. And again my remainder was 1, right? And I will again take this quotient and divide it with 2. 2 1s are 2. And this time my remainder was 0, right? And I will again take this quotient and divide this with 2. 2 zeros are 0. And my remainder was 1. I will do this process until my quotient will become 0. And if you see now my quotient has become 0. So I need to stop my calculation. Okay. Now we need to consider from the backwards. That was binary of 11. We need to consider from backwards, right? So that was 1 0 1 1. So 1 0 1 1. So this is the binary of 11. Okay, let's check whether it's correct or not. In Python, we can use a binoff function. This is the predefined built-in function. And we just need to define the decimal number within this binoff. And if you see, it was 1011. So, and we got 1011 only. So in this way, we will find out the binary of any number. But this method is not a standard way of finding out the decimal conversion of a binary number. So we need to think for the standard approach. The standard approach is very simple. If you see what we are doing, we are thoroughly dividing our number with 2, right? Till my quotient will become 0. So what we are doing? To find out the reminders, we will do n mod 2. And to find out the quotient, we will do n by 2, right? And finally, what we need to do? We need to arrange these reminders in the reverse order, right? In the backward direction. Okay, let's see the logic to how to arrange these reminders in the reverse order. So how we want our binary number? We want it as 1 0 1 1, right? Okay, instead of consider this number as a binary number, let's consider this as a decimal number. If we consider this number as a decimal number, we know this 1 is at the first place, right? And this 1 is at the 10th place, right? And this 0 is at the 100th place, right? And this 1 is at the 1000th place, right? And one more thing, this is the first iteration reminder where we place this at first place, right? And this is the second iteration reminder where we place it at 10th place, right? And this is the third iteration reminder where we place it at 100th place. And this is the fourth iteration reminder which we place it at 1000th place, right? So what are your observations? We need to go in the forward direction only, which means we need to find out the reminders in the forward direction only. And while we are finding out the remainder, we need to place them in backward direction, right? Nothing but we need to keep them in their appropriate places, right? If we get the first reminder, we need to keep it at first place. And if we get the second reminder, we need to keep it at the 10th place. And then the 100th place and then 1000th place. So how to achieve this? It is very simple. How we can write this 1011? We can write it as 1 into 1000 plus 0 into 100 plus 1 into 10 plus 1 into 1, right? We can write the same 1011 as like this, right? So if you observe, this is my first reminder and this is my second reminder, this is my third reminder and there's a fourth reminder, right? And these are my places. This is the first place, 10th place, 100th place, 1000th place, right? So what we are doing, every time we are multiplying our reminders with their places and we are adding them, right? That's it. So simple. So at first we do n mod 2, right? Let us say initially my place was 1. every time my place will be 1, right? So what we are doing? We are doing place into reminder, right? And we need to store this in some variable. And finally, what we are doing? We are appending all these results, right? So for that, let's take a variable, answer variable, and initialize it as 0. And let's append all these results to an answer variable. Simple. And later what we are doing? We are making the quotient as n, right? So how we can find out the quotient? We can find out by n by 2, right? So, and we are making it as n equal to n by 2. And also one more thing, if you observe, in the first iteration my place was 1, and in the second iteration my place was 10, and in the third iteration my place was 100. So every time it was changing. How it was changing? It was changing place equal to place into 10, right? Every time it was multiplying by 10. So we need to change our place also. So this is the logic, guys. So now we need to write the code for it. So before diving into the coding part, let's figure out the logic in simple words. At first, we need to take the input. The input was simple, that was a decimal number, right? N. And then coming to the logic part, we need to implement this logic in our code. So for that, I will use a while loop. And finally, I will print the binary conversion of that decimal number, right? Okay, let's write that. Let me keep a comment first. Program to convert decimal to binary, right? So let's take the input first. N equal to int of input of enter decimal number, right? And later what we need to do? I need to use a while loop, right? So what is my while condition? Where should I need to go till? I need to go till my n is not equal to 0, right? Once my n will become 0, then I need to stop my iteration. So this is the terminating condition, right? So my condition was n not equal to 0. What we are doing? We are finding out the remainder, right? Remainder equal to n mod 2. And now what we are doing? We are computing place into remainder and appending that value to answer variable, right? So for that, what we need to declare? We need to declare our place and answer variables, and we need to initialize the place as 1 and answer as 0, right? Let's do that. So place equal to 1 and answer equal to 0, right? And then answer equal to answer plus place into remainder. Later, what we need to do? We are making the previous iteration quotient as n, right? So let's do n equal to n by 2. We will use the float division in Python to get the precise value. And later what we are doing? We need to change our place variable, right? How? Place equal to place into 10, right? So this is the logic part. Now let's print the output. Print the binary conversion of n. So if I keep n here, then in my output, I will get like the binary conversion of 0 is, because once my n will become 0, I was coming out of the loop, right? So I was losing my value of n. But we can restore the value of n by simply storing it in some another variable. Let us say num variable. So I will keep here num is answer. Simple. Okay, now let's run this program. So I will give 11. So the binary conversion of 11 is 1011, right? Let's run this program again. So this time I will give 5. So the binary conversion of 5 is 101, right? And let me run this program. I will give 20. So the binary conversion of 20 is 10100. So in this way, we will write a program to convert a decimal number to binary number, guys. Hey folks, if you enjoyed this coding tutorial and found it helpful, don't forget to give it a thumbs up. Share it with your fellow coding buddies, drop a comment with your thoughts or questions, and of course, hit that subscribe button and ring the notification bell so you never miss out on our latest content. Your support means a lot and it helps our community grow. Happy coding!